Hi, my name is Taylor and I'm here to do physics video for extra credit. This is my bedroom and I don't know if you noticed, but Justin Bieber. It's calendar, yeah. It's just one of the 12 faces of a year of Bieber. It's great. Don't get too distracted by his face. So, the talk that I went to was about the physics of baseball. It was Alan Nathan, he's a professor at the University of Illinois, and looks a lot like Harrison Ford, scarily a lot. I mean, look at that resemblance. Anyway, so he has spent lots of time in research and everything and learning about baseball in terms of physics and exactly what goes into it. The first part of physics that is in baseball is all physics 1, 100% completely physics 1, so things that we're good at. It's not so much what we're good at in physics 2. But, so the big thing, the three biggest things are Newton's laws, which, recap from last semester last year. First law is an object in motion will stay in motion unless an outside force acts on it. Same, at rest stays at rest. Well, 2, the net force is equal to acceleration times mass. 3, when a body exerts a force on another body, the second body exerts an equal but opposite force on first. So those principles are what you use to calculate like all of this stuff. The biggest thing is collision, right? It's like 8,000 pounds of force in less than a millisecond, which is crazy, right? It's insane. So, and about 3/4, 75% of this energy is lost. That, it does not go into projecting the ball further, which is a huge waste. They calculate the speed of the ball. It's called the batted ball speed. And they have this whole equation for it. So the batted ball speed is equal to Q, the collision efficiency, times the speed of the ball, plus 1 plus Q times the speed of the bat. Looking at that equation, the speed of the bat is way more important than the speed of the ball, which to me is completely counterintuitive. Like everyone in baseball, you talk about, oh, he can pitch that ball 90 miles an hour, 100, and I don't know what's fast, but fast. And that, it seems like, is what people focus more on, and not the speed of the bat. That's ideally the most important part. So Professor Nathan gave an example. He talked about, if you hit a ball off a tee versus bunting the ball. You hit it off the tee and it's going to go as hard as you hit it. The harder you hit the ball, the further it's going to go. When you bunt the ball, it's just like kaput, it just kind of rolls. I mean, it doesn't stop completely opposite, but it just rolls in front of the pitcher's mound and you break for it, right? So if the most important part is the bat speed, then how do you make your bat swing faster besides pure muscle? Well, there's a whole science into that. And the big word of the day, couple words, moment of inertia. Something else that we've learned here. Moment of inertia and weight. So the weight of the bat is a huge factor in the moment of inertia. The greater the moment of inertia, the greater your rotational kinetic energy is going to be. So, you're swinging your bat, and it's like it rotates, right? So you've got a rotation. So you're rotating this way and trying to go this way. It doesn't, the stronger the force of rotation here is going to be more difficult to swing it faster in this direction. The lower weight that's in your bat, you'll have a lower moment of inertia, a lower rotational kinetic energy, and a greater speed. So that's what they look for. That's why you cork your bats, or like an aluminum bat, which is hollow, is more preferred. But aluminum bats, besides just being hollow and weighing less, also have another effect on the ball, which is called the trampoline effect. I had never heard of this before, but so the trampoline effect is essentially why you get higher on a trampoline. It's stretched, you put a force on the trampoline, it goes down, and it springs right back up. Well, it springs right back up before you leave the trampoline, so the energy is transferred into you, making you jump higher. The same thing goes for an aluminum bat. The bat compresses along with the ball compressing, but it springs forward faster while the ball is still in contact with the bat and puts energy into the ball to make it go faster. Whereas with a wooden bat, the bat bends much more and oftentimes breaks, especially if you hit it towards the top or toward the bottom and you don't get it right in that sweet spot. It'll just snap from the compression, and the force of it will just cause it to break. But with the aluminum bat, it compresses and goes back to its original state much faster, increasing the speed of the ball, going further, which is why they're not allowed in the major leagues, because who wants to watch a game where you get a home run every time? That's like super boring. Physics is fun. Ooh. And he's a really cool guy, so you should go Google him. He has a Twitter. I just found it. But if you like my video, please rate it well, because I need 2% extra credit so bad. Thanks.